For question 9, we are first of all asked to find the first 4 terms in ascending powers of x of the binomial expansion 2 plus px all to the power of 9. Okay, so this is equal to 9, choose 0, and our first term, our a term, which is 2 to the power of 9, and then we add 9, choose 1, our first term, 2, is now to the power of 8, and our second term, which is px, not just p and not just x, the whole term, px to the power of 1. Then we've got 9, choose 2, 2 to the power of 7, px all squared, and then 9, choose 3, 2 to the power of 6, and that's not going to fit on, so we're timesing that by px to the power of 3. So that's equal to 9, choose 0, that is equal to 1, so we've just got 2 to the power of 9 there, plus 9, choose 1, that is equal to 9. So we've got 9 lots of 2 to the power of 9 times by px. Then we're adding 9, choose 2, that is 36. 2 to the power of 8, oh sorry, that should have been 8, and this is 2 to the power of 7, times by p squared, x squared, and then 9, choose 4, choose 3, that's 84, we've got 2 to the power of 6, and we've got p cubed, x cubed. So 2 to the power of 9, that's equal to 512. We're adding 9 times 2 to the power of 8, that's 2304 px. 36 times 2 to the power of 7, we've got 4608 p squared x squared. 84 times 2 to the power of 6, that's 5376 p cubed x cubed. Okay, then part B, part B says given that the coefficient of the x cubed term is minus 84, negative 84, find the value of p. So the x cubed term, that is 5376 p cubed. That is the coefficient of our x cubed term, and that is equal to negative 84. So if I divide both sides by 5376, I get that p cubed is equal to negative 1 over 64. So p is equal to the cube root of negative 1 over 64, which is negative 1 over 4. Part II says find the numerical values for the coefficients of the x and the x squared term. So we know that p is equal to a negative quarter. So for the x term, the coefficient of the x term, we've got 2304 times by a negative quarter, which is negative 576. For the x squared term, we have got 4608 times by a negative quarter all squared, and that is equal to 288. For question 10, we've got a diagram showing the position of 3 boats P, Q and R. Boat Q is 7 kilometres from boat P on a bearing of 327, and boat R is 15 kilometres from boat P on a bearing of 41. So this angle here from P to R would be 41. Part A is asking us to find the distance between Q and R to 1 decimal place. Now, I have labelled my sides with the opposite side being the lowercase version of the what the angle is labelled at. So we've got angle P here, and opposite to that I've got lowercase p, r, q and lowercase q. Okay, we're going to be looking at trig here because we're looking at angles in triangles. And for this question, we have got the angle, we can work out this angle here, and we've got the two sides adjacent to that angle. Okay, so we've got the sides, an angle in between two sides, so we can use the cos rule. Now the cos rule, I have rewritten it in terms of P, Q and R. So all we need to do first is calculate this angle here, P. So the angle P, we've got 360. We're subtracting 327, sorry. So if we subtract 327, we'd get this little angle here. But in the question, we are told that the bearing of Q from P is of R from P is 41. So we know that this angle here is 41. This angle here is 360, subtract 327. So we need to add angle 41 to get the whole of that angle there. So 360 subtract 327 plus 41, that is equal to 74. Okay, so we've got an angle P of 74. So we've got that P squared is equal to Q squared, that's 15 squared, plus 7 squared, subtract 2 times 15 times 7, cos 74. So when we type that into our calculators, we'll get that P squared equals 216.11 and so on. So then we're going to take the square root, and we're going to take the positive answer of that square root because we're looking at distance, and we're going to round it to 1 decimal place, and we get 14.7 kilometres. Now we've written that using our own notation of lowercase p, so I'm just going to write down that the distance QR is 14.7 kilometres. For part B, we're asked to find the bearing of R from Q, so that is this angle here. So we're going to use the sine rule to find the angle here, and then use our knowledge of this angle here to calculate that bearing. So let's first of all use the sine rule to find the angle Q. So we know that sine Q over Q is equal to sine P over P. So sine Q over 15 is equal to sine P, which is 74, over 14.7, which we just found in part A. So when we multiply both sides by 15, we get that sine Q is equal to, so we've got sine 74 over 14.7, then times that by 15, uh, 15 times sine 74 over 14.7, we get that sine Q is equal to 0.98 and so on. So we're going to do the sine inverse of that, and we get Q equals 78.77, and so on. Okay, so we now know that this angle here is 78.77 and so on. We want to find the angle here. Now, in order to do that, we need to use our knowledge of angles in a triangle to find this angle here. So I've extended the diagram down into a right angle triangle. This isn't the only way to do it, but this is the way that I would do it. I know that this angle here is 90 degrees. This angle here I can work out using this bearing. So this angle here, I'm just going to call that angle, let's call it W. So angle W is equal to, well, if we look at the bearing here, we've got a bearing of 327, and we can subtract from that 270. So the angles around a point add up to 360, 3/4 of that is 270. So angle W is equal to 327 subtract 270, 327 subtract 270, that's equal to 57. So then if we call this angle here angle Z, we know that W plus 90 is equal to Z. So 180 subtract 57 subtract 90 is equal to Z. 90 subtract 90 subtract 90, which is equal to 33. So we've got an angle of 33 here, an angle of 78.77 there. So our bearing will be equal to 180, which is the sum of all three, subtract 78.77 and so on. I would put in my calculator the actual sine inverse of 0.98 when I find my answer to remain accuracy, and subtract 33 degrees, and we should get an answer of 68 or 0.68 as a bearing.